students. Today I am here again with a new topic on surface chemistry. And dear students, we have already discussed various properties of colloidal solutions. Today I am taking a couple of other properties of colloidal solutions. These properties which we are about to discuss, these are some special properties. However, we have gone in detail regarding the properties of colloidal solutions. Today we are taking two special properties of colloidal solutions. One of them is known as electrophoresis and the other is known as coagulation. First, coming to electrophoresis. Now, this property tells us the charge of the colloid. As you know that our colloidal solutions, they do have some charge. Either they are positively charged colloids or they are negatively charged colloids. Those colloids which are positively charged, they are known as positively, or simply we can call them as positive colloidal solutions. Similarly, there are some colloidal solutions which have negative charge. Their dispersed phase is negatively charged. Those colloids are known as negative these colloidal solutions. Now, the question arises how we can determine the charge of a colloid, whether the colloid is a positively charged colloid or it is a negatively charged colloid. For that very purpose, we have a process known as electrophoresis. By conducting this process, by going through this process, we can determine the charge of the colloid. For this purpose, what we do, we take a U-shaped tube. Please see here, this is a U-shaped tube. This is a U-shaped tube. It has two limbs, limb first and limb second. That is two legs of this tube. Now what we do, we insert two electrodes in it. These are two electrodes. These are platinum electrodes, metal electrodes. These are two electrodes in it. PT electrode. Suppose this is positively charged electrode and this is negatively charged electrode. They are further connected to a battery. This is battery here. Now, what we do, we put the colloid in this U-shaped tube. When we put that colloid in the U-shaped tube, after that what we do, we connect the battery. After connecting the battery, what we find that the particles of the colloid, they either accumulate towards positive electrode or negative electrode. Suppose if there is an colloid here, and suppose if it moves towards this electrode, that is if it moves towards the positive electrodes, that means that this colloidal solution is negatively charged, because negative particles can move towards positive. And suppose if it does opposite of it, suppose it moves towards negative electrode, then this colloid is a positively charged electrode. So this process, this movement of the colloid towards the oppositely charged electrode, please listen that when we conduct this process, during this process, the movement of the colloidal particles towards which end? Towards the oppositely charged electrode is known as electrophoresis. So what is electrophoresis? It is a phenomenon by which what happens in a U-shaped tube, the colloidal solution that moves towards the oppositely charged electrode as well. As soon as we connect the battery. Once battery is connected, the colloidal solution that moves towards the oppositely charged electrode, and it determines the charge of the electrode. For example, if I take an example here, suppose this is antimony sulfide. Antimony sulfide is a colloidal solution. If this colloidal solution is kept in this U tube, what happens to? As soon as we put this this colloid in this U-shaped tube, it has same color throughout the tube. Same color throughout the tube. In this tube, we will find the colloid. It will not accumulate either to this end or to that end. It will have same color. But once we connect the battery, once we make the connections, what happens? The color of this colloid, it becomes intense. And what happens? This colloid moves towards positively charged electrode. It moves like this. These particles begin to move towards the positively charged electrode. What does it mean now? It means that this colloid, that is arsenous sulfide, this is a negatively charged electrode because its particles have moved towards the positive electrode. So this is how we can determine the charge of the electrode. I can take another example. Suppose I have one more colloid, say iron hydroxide, ferric hydroxide. If this colloid is put in this U-shaped tube, what will happen? It moves towards the negative electrode as soon as we make connections with the battery. What does it mean then? It means that this ferric hydroxide is a positively charged electrode. Why? Because its particles have moved towards the negative electrode in this U-shaped tube. So this phenomenon, this process is known as electrophoresis. So electrophoresis can be concluded by taking the final definition, that it is the movement of the colloidal particles towards the oppositely charged electrode when electrodes are connected by means of a battery. So this was one property of these, a special property of the colloid. Then I have another property that is known as coagulation. Coagulation. This property is also known as flocculation. Flocculation or coagulation. Now, as far as this property is concerned, this coagulation means precipitation, settling down. We know that colloids under normal conditions do not settle down. They do not change into precipitates. But they can be made to change into precipitates by a process is known as coagulation. So coagulation means precipitation of a colloid. Now the question is, how a colloid gets coagulated, how a colloid gets flocculated. There are various methods for coagulating a colloidal solution. For example, the most common method of coagulation of colloids is what we do, we add some electrolyte. Some electrolyte is added to the electrolyte. Electrolyte, you know, is a substance either in solution state or in molten state through which current can pass. There are various these electrolytes. For example, this is an electrolyte, NaCl is an electrolyte, molten NaCl. If NaCl is taken in molten state, it behaves as an electrolyte. Then that means current can pass through molten NaCl. So when an electrolyte is added to the colloidal solution, what it does, it coagulates. Now the question is how it coagulates it. I will tell you. What happens? Let me take an example here. Suppose I have an electrolyte, say this, arsenous sulfide. and we know that arsenous sulfide is a negatively charged colloid. Now if we add an electrolyte to it, suppose this is an electrolyte, barium chloride. Now in barium chloride, barium is positively charged ion, chlorides are negatively charged. When the electrolyte is added to the colloid, what happens? One of these ions, whether positive or negative, depending upon the charge of the colloid. Suppose if this is negatively charged colloid, we know arsenous sulfide is a negatively charged colloid. So which ion should combine with it? The oppositely charged. Which is the oppositely charged ion? Barium. So when this electrolyte is added to the colloid, what happens? The barium ion that combines with the negatively charged this colloid, forming neutrality. A situation is at hand and neutralization happens, and as the result of neutralization, your colloid that settles down, that coagulates, that precipitates. So this electrolyte has helped the coagulation of the this colloidal solution, or the flocculation of the. So what is the process now? Process is very simple, that when an electrolyte is added to the colloid, the oppositely charged ion, by oppositely charged ion I mean that if your colloid is negatively charged, then positive ion will combine with this. This will react with. If this is positively charged colloid, then negative ion of the electrolyte will neutralize that, and as a result, the coagulation will take place, the precipitation will take place, the flocculation will take place. We can't. So which ion has done coagulation here? Barium ion. Then we have some other methods of coagulation also. For example, let me take some other methods of coagulation. Mutual precipitation. Now what is mutual? When we have a word mutual, when there is mutual, that means two things must come into action. What are those two things? Now what we do, we take a colloid, say positive colloid, and we take another colloid, negative. So we take oppositely charged electrode, these colloids, oppositely charged. If there is a positive this colloid, we add a negative that colloid to it. On mixing oppositely charged these colloids, coagulation can be attained. So very simple method. For example, this is iron hydroxide or ferric hydroxide. If we mix with arsenous sulfide, now see, this is negative colloid, this is positive colloid. Now if we mix them, what will happen? They will combine to form to get neutralized, and as a result, precipitation will take place. Settling down of the colloid will take place. That process will be known as coagulation. Similarly, we have another method of this coagulation, that is electrophoresis, which we just discussed. Electrophoresis. What is done in this process? Long time. By long time I mean, what we do, we take that U-shaped tube with electrodes, with battery, then your colloid that is kept in the U-shaped tube for a long time. What happens? During this process, the colloid moves towards the oppositely charged colloid, and if we keep them for a longer time, then that colloid gets coagulated. So by electrophoresis, coagulation can also be attained. Then we have another method for coagulation, that is persistent dialysis. Dialysis is a simple process. If a colloid is subjected to persistent dialysis, for regular dialysis, for continuous dialysis, it easily gets precipitated. That means it gets coagulated. So this is another method of coagulation of colloidal solution. And one more method is there, that is heating or cooling the colloidal solution. Sometimes we can coagulate a colloidal solution by either heating or by cooling. For example, let me take an example. If butter is heated, if butter is a colloid, if it is heated, it gets coagulated. Similarly, if milk is cooled to a very low temperature, it too gets coagulated. So, by heating and by cooling, we can coagulate colloidal solutions. Now, before concluding today's topic, I would come to some specific terms which may help you in objective type questions, like some special things. Colloid of gold in water. That means it becomes a colloid, that is gold in water. This is known as this is also known as gold sol, AU sol. That means the colloidal solution. This colloidal solution is also known as purple of Cassius. Please remember, gold solution, that is gold in water, is also known as purple of Cassius. It can help you in objective type questions. Similarly, silver in gold colloid, silver in water rather. Silver in water, this colloid, that is silver in water colloid, it is also known as argyrol. So what is argyrol? Argyrol is a colloid of silver in water. This is a medicine. This is a drop which can be used as eye lotion. It's a lotion. It is used as an eye lotion. So what is an eye lotion now? What is argyrol? Argyrol is silver in water colloidal solution. Similarly, if we have antimony in water colloid, this is used as a medicine for treatment of a disease known as Kala-azar. Kala-azar is a disease. For curing this disease, this colloid can be used. This is another objective type question. Similarly, if we have this colloid is used for curing antimony poisoning. If some patient has got poisoning due to antimony, if he has been poisoned by this, then to cure this, what is done? This colloid is given to such a patient. What happens when this colloid is given? He vomits this poison by using this colloid. So this colloid helps him in vomiting, and by vomiting the poison comes out and the patient gets cured. Then similarly, we have another colloid, graphite in water. Graphite in water, such a colloid is known as aquadag. Please remember what is aqua for water. Aquadag is a colloid of graphite in water. But if instead of water we have oil, then it becomes another colloid, graphite in oil colloid. And such a colloid is also known as oil dag. So what is oil dag? Oil dag is a colloid of graphite in oil, and aquadag is also a colloid of graphite in water. So these are some objective type questions, and for today this is all. Thank you very much.